coming to the next question, it says that the cut length of a staple polyester fiber is approximately equal to the effective length of a specific variety of long staple cotton fiber. When these two types of fibers are blended in nearly equal proportion, the typical comb sorted diagram of the blended fiber tuft is. So what actually it says that one is a polyester fiber and it is blended with a specific variety of a cotton fiber. So when these two fibers are blended together, then they says that what type of the comb sorted diagram would be formed in this case. So you need to know that in this particular case, if you have read about the comb sorter diagram, this is actually they try to confuse the people, but in this particular case the cut length of the staple polyester is equal to the effective length of the long staple cotton fiber. So in which case you can see that the cut length of these two fibers are same. So if you see all these diagrams, then in option number B only, the cut length of the fiber is same, fiber length is same as proportionate to the polyester as equal to the cotton fiber. So this is same till here it is, and in this case so option B is the correct answer. I think it is very much clear. It says that during the measurement of the cotton fiber fineness in micronaire is a unit of a fiber fineness, by airflow method, the higher quantity of cotton fiber is taken by mistake than is specified. The reading of the micronaire value from the instrument will be. So it is a conceptual question. Which type? What they said that if by mistake anything is done wrong in measuring the cotton fiber fineness, the quantity of the fiber that is taken is higher, then what would be the correct reading of the micronaire value? It would be higher than for any fiber fineness, lower for any fiber fineness, or lower for any coarser fibers, or lower for only finer fibers. So basically you need to know that the reading, if the measurement higher quantity is taken higher, then the micronaire value would be lower for any fiber fineness. Matlab it does not depend upon the fiber fineness. Basically how? If the quantity of the fiber is taken, higher quantity is taken, the air flow resistance will be higher, leading to lower micronaire reading. How this actually happens is, if the quantity is higher, then you know that air flow resistance is higher, and this leads to lowering of the micronaire value, because when the instrument is calibrated to measure the airflow resistance of a specific quantity of fibers, and when there is any deviation, which type of deviation, either on the higher end or either on the lower end, then from that quantity it will affect the accuracy of the measurement. Then the reading of the micronaire would be lower regardless of the fiber fineness. Means it does not depend upon the fiber fineness, irrespective of either it is higher or either it is lower. So the value of the micronaire would be lower for any fiber fineness. So option B is the correct answer. Now coming to the next question. That says that for the same turns per unit length, as the yarn becomes coarser, the twist angle decreases, the twist angle increases, the twist multiplier decreases, and the twist multiplier increases. So if I talk about what is actually this thing saying, if you know the formula, that then TPI is equal to TM into under root NE. Twist per inch is equal to twist multiplier into under root of count. So as you can say that the count is inversely proportional to the twist multiplier. Any is indirect count. So for coarser yarns, the twist multiplier increases. If I say that twist multiplier, so if the count is higher, then the twist, if any is higher, then the twist multiplier is lower. If any is higher means finer count. If any is lower, then the twist multiplier is higher. So for coarser count, the twist multiplier increases. Since any is an indirect count, means for coarser yarn, the any value of any should be lower. If it is lower, then the twist multiplier is higher, and vice versa. And this direct count systems are text. So if text increases means the the fiber coarseness increases. If the text decreases, then the fiber is finer. So option D is the correct option. Twist multiplier increases. And if I talk about the twist angle concept, so what happens with the angle? So if you know that as the yarn becomes coarser, the diameter of the yarn increases, which means for the same number of twists per unit length, it will cover shorter length. This results in increase in the twist angle also. So the twist angle increases. I think it is clear. Option B and option D is the correct option. This is how you need to proceed with these types of questions. Now coming to the next question, it says that a PET sample with 40% crystallinity shows a melting endotherm in the first heating cycle of DSC with a melting enthalpy of 50 joule per gram. The degree of crystallinity of another PET sample in percentage, which also shows a melting endotherm with a melting enthalpy of 80 joule per gram. So how we will do with this question? So there are two PET sample. For taking with the first PET sample, if we talk about the first PET sample, then it says that the crystallinity that is given is 40% and the enthalpy is given as 50 joule per gram. And for second PET sample, the crystallinity we need to find and the enthalpy is given as 80 joule per gram for second PET sample. So how we will proceed with these samples, since as we know that both these samples are PET samples, means polyethylene terephthalate samples. So if we say that these both samples are of same fibers, so if we say for 50 joule per gram enthalpy, the crystallinity that is 40%. So for 1 joule per gram, the crystallinity would be 40 upon 50. And if we talk about 80 joule per gram, then the crystallinity is 40 upon 50 into 80. If we solve this, then it comes out to be around 64%. Then the crystallinity in percentage is 64%. This is the final answer that we need to calculate. So the crystallinity in percentage of another PET sample, since both these are PET, then these are both are of same quality. So if we need to find out these things, then it can be solved it accordingly. So the answer is 64. I think these questions are very much clear. This type of questions are very much asked in the as per the latest pattern of GATE examination. So now coming on to the next question, it is also a numerical answer type question. So these are NET type of questions in which there is no negative marking, but you need to have some level of accuracy for these questions to solve at their best. So now coming to this question, it says that a ring spun yarn with mean linear density of 32 ticks is produced from two linear polyester staple fiber. If the standard deviation of the yarn linear density is 3.2 ticks, then the index of irregularity of the yarn up to 1 decimal place. This you need to calculate. So how we will be doing this type of question? So basically, if I talk about this type of question, so in this question, what is given as standard deviation, and if you know about the standard deviation, then the things, it is 32 ticks yarn, 32 ticks linear yarn, and sigma linear standard deviation is 3.2 ticks. So you have to calculate first for index of irregularity. You need to calculate CV percentage, coefficient of variation percentage. Then how we will calculate CV effective? It is sigma upon x bar. This is x bar. This is the yarn linear density. So CV effective sigma upon x bar into 100. This is the formula of CV. So if we will calculate this 3.2 upon 32 into 100, then CV percentage comes out to be 10%. And for this we need to also calculate this number of fibers. So for number of fibers, if you will calculate, this is 32 ticks yarn, and for fibers, the polyester staple fiber is 2 denier. So both of these should be in the same unit. If I talk about this number of fibers is yarn ticks upon fiber ticks. So for yarn ticks we will calculate, then it is 32 ticks upon fiber ticks. So it is, since it is 2 denier, so 2 by 9 ticks, both are in ticks, then we will calculate it accordingly. 32 into 9 upon 2, 16 into 9, 144, n is 144. So number of fibers that is coming is 144. Now if we will calculate this thing, then how we will be doing this? So CV limit, the formula is, for general it is 100 upon under root of n. Then if we talk about 100 upon under root of n is number of fibers we have calculated is 144. So 100 by 12, it would come out to be 8.33 CV limit. And you know the formula of index of irregularity, I is equal to CV effective upon CV limit. I is equal to CV effective upon CV limit, 10 upon 8.33. It would come out to be 1.2. So the final answer is 1.2. So you have to answer in 1 decimal place. So the answer is 1.2. So in 1 decimal place, 1.2 is the right answer. So this is a 2-mark question. So if in any type of questions where you will need to find the index of irregularity, you have to calculate the CV effective and CV limit, then you have to form it accordingly. It says that with reference to the work factor and the work of rupture of the two yarns with the same breaking load and same breaking elongation, the correct statement is or are is option number A. The work of rupture of a yarn with work factor 0.3 is more than work factor 0.5. The work of rupture of the yarn with work factor 0.3 is less than that of work factor this. If the breakage takes place within the hooks region, this is very important, hooks region, then the work factor is more than 0.5. If the breakage takes place within the hooks region, then the work factor is equal to 0.5. In this question you have to determine, this is a textile testing question, and you have to determine what is the correct options. So if two yarns having the same breaking load and breaking elongation, suppose the load and breaking elongation is same, then they will have the same breaking energy, that you have to remember. In these cases, the yarn with the lower work factor will have higher work of rupture. Yarn with lower work factor will have higher work of rupture. Work of rupture means the work required to break the fabric under the load elongation curve. So basically it is under the area under curve. If I talk about the work of rupture, you have to calculate, then it is area under curve. Then you directly integrate the portion that is given, and you will get the work of rupture or the toughness, if I talk about in the general terms. So also if the breakage takes place within the hooks region, it means that the yarn has not exceeded its elastic limit, and it must have undergone the plastic deformation. What is this plastic deformation? When loaded, then it occurs during the elongates closely. It is the elastic region, and this is somewhat occurs. This is the plastic region, and it finally breaks here. This is known as breaking load. And this is elastic region, this is plastic region, and it is the final deformation. This is known as deformation. So load versus elongation curve, this is known as breaking load, this is known as breaking load, and this is the elongation, and this point is known as breaking strain. So the modulus is basically stress by strain. If I talk about this stress by strain, this is the modulus. So the work done is equal to the work done in the elastic region of the stress strain curve, and the work factor will be equal to 0.5. So it is an ideal limit. You must have to remember this work factor is equal to 0.5. So what are the correct options? The work of rupture will work factor low, then higher work of rupture means 0.5. Option B is the correct option. If breakage takes place within the hooks region, then work factor is equal to 0.5. This is the ideal condition that we must have to understand. So option number B and option number D is the correct option. I think it is clear. So this is a textile testing question. It says that among the classmate faults A2, B1, D4, H2 and I1, the correct statement is or are D4 and A2 are the thickest fault and the shortest fault respectively. I1 and H2 are the longest fault and the thinnest fault respectively. D4 and I1 are the thickest fault and the thinnest fault respectively. And B1 and H2 are the most objectionable fault and the longest fault respectively. So you have to remember this table for the classmate test. A4, B4, D4, C4, D4. These are the highest objectionable fault, and when you decrease down the line, then the objectionable fault decreases, and the fault considered as non-objectionable faults or minor faults as far as classmate test is concerned. So in this I2, I1 is the thickest fault. Among the fault, I1 is considered as the longest fault in all these. If you read about the classmate fault, and it is basically based how these are classified. So these are classified. These are basically yarn faults that are classified based on the specific range of thickness and length. So all these faults are basically the errors that occurs during the yarn process, and these are defined by the thickness and the yarn faults and length. So if I talk about the faults A2, B1, D4 and H2 and I1, so the thickest fault among all this is D4. D4 is the thickest fault, and A2 is the shortest fault. A2 is the shortest fault. higher the number, the more thickest the fault is. And I1 and these all are below this axis, and I1 is this side of this axis, and I1 is the longest fault. I1 is the longest fault and H2 is the thinnest fault. So option number A, option number B is correct. Thickest fault is D4, and I1 is not the thickest fault, and I1 is the basically the longest fault. Thickest fault and thinnest fault is not considered by I1. Thickest fault is D4 and thinnest fault is H2. So if I summarize this thing on a basis, so you can say that H2 is the thinnest fault, I1 longest fault, D4 thickest fault, A2 is the shortest fault. You must have to remember these things based out of your classmate test. Option number A, option number B is the right answer. Now coming to this question, it says that these are NET type of questions. It says that in a melt spinning of monofilament, a polymer is being extruded at a volumetric flow rate of 5 into 10 की power minus 5 meter cube per second with a spin rate of circular cross section. If the take-up velocity of the first winder is 100 meter per second with a draw ratio of 50, then the diameter in millimeter of the spin rate orifice rounded off to 2 decimal places. This is a numerical type of answer question. So what is basically given is the volumetric flow is given. Volumetric flow. How we will have to do? We will see in this question. Volumetric flow is given as 5 into 10 की power minus 5 meter cube per second, and the take-up velocity is given as 100 meter per second. Draw ratio is 50. So how draw ratio is calculated? If you know this is a circular cross section area, then draw ratio is equal to if we have to calculate the volumetric flow is given, and if I have to calculate the volume of this, so the draw ratio basically is draw ratio is this volumetric flow that is given as 5 into 10 की power minus 5 upon the volume of this this orifice, this spinette circular cross section area. So volume is area into velocity. So if we will calculate this, so pi d square by 4 into velocity is given as take-up velocity is given as 100. So we will have to multiply this. Then what we will get is draw ratio is compared. Draw ratio, we will check here ki how this draw ratio is calculated. So this draw ratio, if I talk about this draw ratio is 50, then 5 into 10 की power minus 5 meter cube per second upon pi d square by 4 into 100. Pi d square upon 4 into 100. If you will calculate this, d square is 5 into 10 की power minus 5 into this meter per second. Second cancel, meter square. And this when you will calculate into mm, so 1000 mm into 1000 mm ka square, because you have to calculate in mm, and pi by 4 into 100 into 50. And since it is an mm, d square, using the gate scientific calculator you can find out this value, and it will come out to be 5.64 mm. Let us calculate this value using the gate calculator. So I have calculated this value and it will come out to be around 5.64 mm, and the correct range that the gate people that the official answer key has was in the range of 5.64 to 5.70. Note that it is asked in 2 decimal place, so the correct answer is 5.64. Many a times what people do is they write the right answer, but they often forget to write what basically asked is in terms of 2 decimal place, 1 decimal place, or integer type of question. This must be carefully mentioned and this must be taken into account very seriously. And it is a 2 mark question, numerical answer type question. Now coming to the next question. Now coming to this question, it says that a 30 tex cotton yarn is made into a lee of 120 yards for determining the count strength product. If the lee strength is 500 Newton, then the CSP of the yarn is rounded off to the nearest integer. Then you know that this is a direct question of a textile testing part. You know that CSP is basically the yarn strength in pounds into the yarn count into in indirect count. It is an any count strength product is basically this. So yarn strength in LV you have to calculate. It is given as a what is given as 500 Newton. So if you will have to calculate this 500 Newton in pounds, then this 500 upon 9.8, you know that it is in pounds, then you will have to calculate in 2.204, it is pounds, then multiply by the indirect count. Then how you will have to calculate this one? This one is calculated by using 590.5 upon tex. So the formula of NE is basically 590.5 upon this. Then you will calculate the count strength product. It will come out to be 2211.79. It will directly approximately come out to be 2212. In integer you have to calculate, then the correct answer is 2212. I think this is clear to you.